In this video, I'm going to show you how to utilize user-defined types to speed up your VBA applications and to optimize your code. With user-defined types, you can create custom data types tailored to your specific needs, resulting in more efficient code and faster execution times. And who doesn't want faster and more efficient code? You can download the code in this video from the description below and try it out for yourself and even use it in your own projects. So let's go ahead and get started. User-defined types are a simple structure that allows us to group related variables together. To create a user-defined type, we simply use the word type followed by the name that we wish to give it. We then add variable declarations to each line using the variable name, the keyword as, and the variable type. To terminate the type declaration, we use the line end type. To use a user-defined type in our code, we declare it as a variable using the name that we provided as the data type. We can then access the members by using the variable name followed by a full stop. We can then use the variables just like we would use normal variables. To make our life easier, we can use the with statement so that we only need to type the variable name once. User-defined types may seem like a simple concept, but they allow us to do some very powerful things in VBA. Imagine we are creating a 3D application that requires us using X, Y, and Z coordinates throughout our code. Moving these variables around our code can get very messy. For example, imagine we want to return a position from a function. One way we can do this is by using X, Y, and Z as by-ref parameters. The problem with this approach is that it is not obvious to anyone reading the code that the variables are being updated in this function. And if we added an extra parameter that was not returning a value, it gets even more confusing. A simple way to solve this is to group the variables in a user-defined type. We don't need to declare and pass them individually as parameters, we can simply treat them all as one variable. We create a user-defined type called position and we add X, Y, and Z as the members. How we use it is as follows. We replace the X, Y, and Z declaration with one single variable declaration for position. Then we assign the position variable to the function. We remove the parameters from the function. We set the function return type to be position. And now we update the code in the function to use a position type variable and we return that variable. Now we can make the code even simpler by adding a with statement if we like. When you compare this code to the original, you can see that this version is much cleaner. Of course, this example has very simple code. With more complex code, the benefits will be considerably greater. You might be wondering if you could do something similar to this with class modules. And the answer is absolutely. We could create a class module with similar members and the code would look like this. The main difference is that with class modules, you need to use the new and set keywords, which makes doing this slightly more complex. At the end of the video, we will see how class modules and user-defined types compare in terms of speed. When you apply user-defined types to your code, you may come across the following error message. If creating cryptic error messages was a sport, then this one would be the heavyweight champion of the world. What it means in simple terms is that a user-defined type cannot be converted to a variant. And what this also means is that they cannot be used with a collection or a dictionary. Now this may seem like a major drawback, but luckily for us, they can be used with arrays, and arrays are the king of VBA data structures. It is very straightforward to use a type structure with an array. It is the same as declaring an array of any basic variable type. We declare an array called myPosition and we specify the type as being 1 to 5. This means we now have 5 variables of type position in our array. Let's see exactly what the array looks like when the code runs. We click in the left margin to create a breakpoint to pause the code at this line. We run the code. When the code stops, we right click on the array variable and select Add Watch. And then we press OK. This adds the array to the watch window. We click on the plus in the watch window to expand the array. If we expand individual members, you can see the variables for those members, which currently contain the default starting values, which in this case is 0. If we want to update a type value in the array, we can do it like this. We use the number of the position we wish to update. When we do this, IntelliSense displays the available members, which makes it easy for us to select whichever one we want. We then set the value of the variable x to be 6. We run the code again, and now you can see that for the user-defined type in position 2, the x variable has been set to 6. If we want to set the size of the array when the code is running, we can use readdim. This is useful as in most real-world applications, we will deal with changing data. When we declare the array, we don't specify the size. Then we use readdim to set the size that we want. We can use a variable in the readdim statement. For example, we could get the number of rows of data and then use this to set the size of the array. Each time we use readdim, it recreates the array, and this means we will lose any existing values that we already have. If you want to keep the existing values, then you can use the preserve keyword with readdim to resize the array. When we run the code, you can see that we now have 6 elements in our array, and if we check position 5, you can see that the type there still has its values. Using preserve is important because often in real-world applications, we may not know the number of items in advance, and using preserve allows us to easily add new ones. Most applications in VBA are made up of 3 parts. We read data from the worksheet, we make some changes to the data, and finally we write the data to the worksheet. User-defined types can be very useful in the scenarios where we want to deal with data in individual columns. Let's look at an example. Imagine we have this data here on fruit sales. We want to create a report where the product name is Apple. We only need 3 columns for the report, and these are product name, volume and net sales. So our finished report would look like this. This is a very simple example, but a great demonstration of how user-defined types can be used. Let's write the code to create this report. First of all, we create our user-defined type. This has 3 variables, one for each column that we're going to use. We then create our main procedure. We declare an array of type sales, and we pass this as a parameter to read sales data. Read sales data will read through all the data and return an array of type sales. Arrays in VBA must be passed by reference as parameters. This means when we change the array in the sub, the original will be changed as well. We call the second sub write to worksheet. This will take the array as a parameter and write the contents to the worksheet. So let's write the code for the read sales data first. The first thing we always do when reading data is we copy it from the range to an array. And the reason that we do this is because it's much faster to process it through an array. So I've created a function here, range to array, and all this function simply does is it takes the range and it removes the header. So our range is going to be A1 and current region, which is all the adjacent data. Now if we look in our range to array function, you can see that it simply moves the range down 1 and then resizes it to 1 less. And what this is essentially doing is removing the header. So I use this as a function because otherwise I need to write 3 lines of code every time. So once we have the data in our array, we simply read through it. Now I is going to be used in our for loop, and count is going to be used to count the number of items in our my sales array. And that will start at 0. So for each item we check if the first column contains Apple. And if it does, then we want to add it to the array. So we want to increase the array size by 1. Now count is 0 by default, but it's always good to explicitly state that so that if somebody isn't familiar with VBA, that they understand what's happening. Now once we have count set, what we do is we redimension our array. In other words, we resize our array. We use preserve to keep the existing values, and we set it to count. And this basically is just adding one more entry to the array. And with this new entry position, we're going to update the 3 columns. So in other words, we're going to update our type structure. We're going to set the values for these, and we're going to use the fields 1, 3, and 6. And when we've this done, we just end our with statement, we end our if statement, and we terminate the for loop using next. And this is it. This is our code written that filters by Apple and reads the appropriate columns. So we'll test that code. We run the code so that it stops at write to worksheet, and then we drag my sales into our watch window and we look at what's there. So we've only got 2 entries, which is correct, and they're both for Apple. So we can see the net sales and volume, and we can see that my sales 2 also has Apple, and we can see the net sales. So we see that it's actually given us the correct data as we expected. So the fastest way to write out our data is to write the data to an array first, and then write that array out to the range in one go. So we create an array here, output sales, and we're going to set it to the size of our my sales array. So it's got the same number of rows and it's got 3 columns. So 1, 2, 3. So now we create our loop and we're going to read through the my sales array. We're going to copy the data from there to the output sales array. So we say output sales, the first column, which is 1, and that's going to equal to my sales and the current item, and that's going to be product name. And so we'll copy this line again, and the next one's going to be net sales, and the next one's going to be volume. And they're going to go to columns 2 and 3 respectively. And then we end our for loop. So what we want to do first of all is we want to clear any existing data, and it's always a good idea to do this. And I've got a simple function called clear data body, and we just give it a range, and the range is where we're going to write it out to. And what this does is it clears the range, but it doesn't clear header. So if you look there, it gets the current region, moves down 1, and then clears the contents. And again, we just used a sub here to do this because it just makes the code that bit neater. And then to write out the array to the range, again, I've got a sub, and this is array to range. When we write out an array to a range, we've got to resize that range to the size of the array. And that's simply what I do with this sub. So we give it the range and we give it the array, and it will resize for us. So again, it just makes the code a bit neater. It means we don't always have to think about how we need to resize the range. You can see the definition of it here. And the definition is quite simply using ubound1 and ubound2 to get the size of the range. So let's run this code and see exactly what happens. And you can see we got the results as we expected. You can see that using type definitions makes our code concise, makes it very readable, and makes it run extremely fast. So how do type definitions compare to class modules in terms of speed? So I created 2 new versions of this example, one that uses a class with an array and one that used a class with a collection. And if we look on the screen, you can see the results of the speed test. Now this was done over 200,000 records where we're filtering 20,000 records. And you can see that using the type is considerably faster than using the class module. And this is because it takes a little bit of extra time to create the class module. So when we're dealing with basic data types like this, the user-defined type is actually a much faster method to use. Now, if you enjoyed this video, please click on the like button. And if you'd like to get notified of my upcoming videos, then click on the subscribe button and the bell icon beside it.